So far, we have introduced several ROC libraries. And now, let's go through a summary. So in this section, we talk about the libraries that we want to use. Why we want to use libraries? We want to use libraries because those libraries are highly performance optimized and are highly reliable. It's very unlikely that you are going to experience a bug in these libraries. It reduces the developer's effort because it is very challenging to write those libraries and beat the performance of first-party libraries. We have also compared ROC libraries and heap libraries. The ROC libraries emphasize native performance and provides the implementation of those algorithms for AMD GPUs. Heap libraries emphasize probability. It serves as a wrapper of ROC libraries and also CUDA libraries. If you write a program with heap libraries, you can port it between AMD GPUs and NVIDIA GPUs. It will eventually use CUDA implementation on NVIDIA GPUs and ROC implementation on AMD GPUs. But anyway, these two libraries have very similar interface. Once you know how to use one library, you can easily convert to another library by reading the documentation of these libraries. In 4 different videos, we also introduced several individual libraries, including ROC BLAST, ROC Sparse, ROC Rand, and ROC FFT. Those are very commonly used algorithms. They can save you a lot of time when you implement more complex algorithms. If you want to prepare the knowledge that you have learned in this section, you can try these 2 assignments. You can use ROC Sparse to implement a PageRank algorithm. There are a ton of videos and documents that describes how PageRank works. And the real work is how to convert the PageRank algorithm into a sparse matrix to vector multiplication problem and use the ROC Sparse library to implement this algorithm. And second, as we have done this before, we can use the Monte Carlo method to calculate pi. And previously, we generated a random number with the CPU. And now we have an implementation that can generate random numbers on the GPU and is expected to be faster than generating random numbers on CPUs. We can try to use the ROC Rand library to calculate pi. And in the next video, we're going to start a new unit. In Unit 10, we will talk about how to use multiple GPUs to further improve the overall performance.